Hi, this is Jim Clary, and again, welcome to our YouTube video, AERMOD Training. In this video, Sarah will first describe the input file, then we'll give you the opportunity to pause your computer while you get to your modeling example directory and get ready to execute it, and then you can follow her along as we go through the execution using that input file to generate an input file that will be used later on in the AERMOD system. Just one quick reminder, you'll see that the explanation of the input file can get rather detailed. Don't be too concerned about it at this point, because remember, a real advantage of these videos is you can always go back to them for reference as you need to as you work through your actual projects. So I suggest that in this one that you just follow along with Sarah. It'll give you a good broad idea of what the input file looks like, but don't be too concerned about sweating all the details at this point. Without further ado, I'll turn it over to Sarah.
I'm Sarah with AERMODtraining.com. I'm going to show you how to set up and run AERSURFACE in this training video.
AERMET requires surface characteristics that are generated by AERSURFACE, so we need to run AERSURFACE before we can run AERMET. EPA created AERSURFACE to determine surface characteristics from the US Geological Survey, or USGS, National Land Cover Data 1992 archive. We have another video that describes how to download the National Land Cover Data. The National Land Cover Data are split into 21 categories, and each category is assigned a seasonal value for 3 surface characteristics required by AERMET. The surface roughness length is the height in meters above the surface at which the horizontal wind speed is 0 based on a logarithmic scale. In areas with a smooth surface, like open water, the surface roughness length will be very close to 0. This value is greater in areas with a rough surface. For example, wooded areas have a roughness length of 1.3 meters. The albedo is the fraction of solar radiation reflected back to space by the Earth's surface. This value is dimensionless, and typical values range from 0.1 for areas where most of the solar radiation is absorbed, like areas of open water, to 0.9 for areas where most of the solar radiation is reflected, like areas with fresh snow. During nighttime hours, the albedo is set to 1. The Bowen ratio is also dimensionless and is the ratio of sensible heat flux to the latent heat flux. It indicates the amount of surface moisture that is available. And it's important to note that the surface characteristics are based on the location of the meteorological tower, not the project site. The surface roughness length calculations are based on a circular area within 1 kilometer of the meteorological station, and the Bowen ratio and albedo calculations are based on a 10 kilometer by 10 kilometer area centered on the meteorological station. First, I'm going to explain the variables defined in the AERSURFACE input file. This file is titled ex1_airsurf.imp. The first input is the National Land Cover Data GeoTIFF file. Our file is located within this folder here, so you must include that before the file name. Next, you enter the output file name. This file will contain the surface characteristic values that are input into AERMET. And next, we need to define the center point of the area. And as mentioned, the surface characteristics are based on the meteorological station, not the project site. And we're going to list the UTM coordinates, so we enter UTM here, which is followed by easting and northing in meters. And then we list the UTM zone. Next, we list the reference datum, which is the NAD 83. Then we have the study radius for the surface roughness length. The recommended default value is 1 kilometer, and if you use anything else, you're going to need to justify the value. Next, we enter yes because we'd like to divide our area into sectors. The sectors can be no smaller than 30 degrees, so the maximum allowed sectors is 12. Since we want 12 sectors in this example, you do not need to define the sector widths. If we were to select a value less than 12, you would need to enter the starting direction for each sector. Next, we determine the temporal resolution. You can pick annual, monthly, or seasonal here, and for our example, we're using a seasonal resolution. Next, we enter no to signify that snow cover is not continuous during the winter months. There are many different parameters that you can define here for the temporal resolution and the continuous snow cover, but it's beyond the scope of this video, so please see the user's guide if you would like more information. So next, the meteorological station is an airport, so we enter yes here. This entry is needed because AERSURFACE determines the surface characteristics from the commercial/industrial/transportation category differently if the site is located at an airport. Next, the project is located in an arid region, so we enter yes here. This entry is needed because AERSURFACE determines the surface characteristics from the shrubland and bare rock/sand/clay categories differently in arid regions. If you select that the location experiences continuous snow cover for at least 1 month, AERSURFACE assumes that the area is in a non-arid region, and this prompt can be omitted. This entry determines if the average wet or dry based Bowen ratio will be used. To determine if the modeling period is average wet or dry, compare the precipitation total for the modeling period to the 30-year climatological average. If the precipitation total is in the upper 30th percentile, select wet. If the total is in the lower 30th percentile, select dry. Otherwise, enter average here. The 2014 precipitation total was in the lower 30th percentile, so we will set the surface moisture to dry. I'm showing the 12 sectors that we defined to calculate the surface roughness length. The left image shows the sectors within Google Earth, and the right image is showing the sectors in relation to the National Land Cover Data GeoTIFF file. The sectors start with 0 degrees or north and increase by 30 degrees as we go around. So this is sector 1, 2, 3, and so on. So the National Land Cover Data shows that the area is comprised of shrubland and grassland. It's a good idea to compare the land cover data to Google Earth to ensure there haven't been any major changes that could affect the surface roughness length calculations since the 1992 data was made. And you can see between the two, there haven't been any significant changes in the Google Earth image. Now I'm showing you the 10 kilometer by 10 kilometer area that we defined to calculate the Bowen ratio and albedo. This area has more land cover categories such as wetlands here, we have some pasture and row crops here, and then we also have some residential areas. And again, you can compare this area to Google Earth to ensure there haven't been any significant changes.
Thank you, Sarah, for that excellent explanation of the input files. We're now ready for you to actually run the program that will generate an output file that will be used later on as we move through the AERMOD modeling system. So put this on pause until you're ready, you got your computer ready, you've got your modeling directory open, and you're ready to follow Sarah along as she walks you through the program execution.
There are two ways that you can run AERSURFACE. The first is using an input file and running AERSURFACE using the batch file. The other option is an interactive mode. You run the executable using the command prompt and you enter the required information when prompted. I'm going to show you both methods. First, I'll demonstrate how to use the input and batch files because it's the easiest option. So go to File and open Command Prompt, and all you need to do is type run_airsurface.bat, then enter. So all the inputs were in the input file we discussed earlier, and it runs through all the different options. And next, we'll do the interactive mode. I'm going to open a new command prompt. You'll need to type the path to the executable. And then hit enter. First, you're prompted for the land cover file. So it's in the NLCD folder, and the name is ex1_nlcd.tif. So next you enter the output file that you would like. Ours is ex1 under AERSURF.out. Then you enter the type of coordinates. In our case, we are listing UTM. Then you enter the easting, then the northing, and then the UTM zone. And our datum is NAD 83. And the radius we want to use to calculate the surface roughness length is 1 kilometer. And yes, we want to define it for multiple sectors. And we picked 12, the maximum value allowed. This gives a little background information on the options that you can do for the temporal resolution. And we know we want ours to be set to seasonal. Our site does not experience continuous snow cover, so we will put no. And our site is an airport. And it is an arid region. And our modeling period was dry, so we entered D. And that's what it takes to run AERSURFACE in the interactive mode. You can close the command prompt, and AERSURFACE outputs the aersurface.dat file. If you use the input file, these two values, or these two data files, should be exactly the same. But it also helps if you use the interactive mode, it summarizes all the input options that you used. The file that is going to be input into AERMET is the ex1 underscore airsurf.out. So when we open that, you'll first see that there's comment lines which summarize the different options in the modeling run. Next, we have a warning message here that you can ignore because the spatial resolution of the land cover file was 30 meters. So the frequency sector keyword here is a keyword where you list the frequency and the number of wind sectors. So we chose the temporal resolution to be seasonal, and we picked 12 sectors. Next, you define the sector widths using the sector keyword here. So you list the sector number, and then you list the start and ending degrees. So 0 is due north, and since we picked the maximum of 12 sectors, each sector is going to increase by 30 degrees. The surface characteristics are defined next. The comment line here notes the order of the variables for quick reference. So for the site underscore CHAR keyword, the season is listed first, 1 is for winter, and then you have 2 for spring, 3 for summer, scrolling down you have 4 for autumn. Then you have the sector number, and then you list the albedo, the Bowen ratio, and then Z0 signifies the surface roughness length. Now that you have the file containing the surface characteristics, you're ready to run AERMET.
If you run into a problem with any part of your AERMOD modeling project, we offer online AERMOD training help that you can purchase from AERMODtraining.com. During our session, you'll be able to ask us any question related to your AERMOD modeling project. And please don't forget to subscribe to our YouTube channel, AERMOD Training, so you'll be notified when we upload any new videos. That's all for now. Thanks for watching.